Good afternoon, everyone, and welcome. My name is Ishan Khanna, and I'm here today to share about how we at TikTok have been working hard to make the lives of our developers pretty awesome. We have a team globally present, and developer experience matters a lot to us. But before you give the next 40 crucial minutes of your life to me, I would quickly like to tell you who I am and why you should listen to me. So I'm an engineer who's been building Android apps for a little over 12 years now. Deeply passionate about developer experience, A/B testing, build and product performance optimizations. I currently serve as a tech lead for the mobile infrastructure team here at TikTok in the US. And lastly, I'm also recognized as a GDE for Android. Now, before we dive in, I think it would make sense for us to know what the agenda looks like. And now that you know a little bit about me, let's see what do I have in store for you for the next 40 minutes. For the first half, I want to share with you what developer experience really is, why does it matter, and why should you even care about it? What are some of the challenges that we face within our teams and our business or feature development teams? And how do we try to solve those challenges? Of course, we're not able to solve for everything, otherwise we'd be out of jobs. And in the second half, I'll dive into some specific tooling that we use, which we built to enhance developer experience by solving those specific problems that we've faced in our build environments. And I do want to point out that you may or may not encounter these problems in your own development environments or teams, but you would get an idea of what you could expect when your app grows super large, or your team grows into a very, very large size, or your code base grows into a large size, and you want to offload some of those problems to a bot or a script. So what exactly is developer experience? I personally define developer experience as the overall environment, tools, processes, culture that mobile engineers specifically interact with daily. And it includes ease of setting development environments, or the efficiency of build and deployments, the clarity of documentation that you would have for things that you've built in-house or the things that you're trying to use from third-party sources, and also the responsiveness of the support systems that you currently have in place to help the teams that are building features or doing development using your toolchain, how quickly can they get their questions answered, problems fixed, or bugs resolved. For mobile engineers specifically, when I'm talking about these aspects, I'm particularly interested in the IDE setup. So when you download Android Studio or IntelliJ, how quickly can you get a developer to make their first build or even submit their first merge request or a pull request? What does the build performance looks like? And how many of you here are actually Android engineers? Not surprised at all. And how many of you are frustrated when you hear the message that says Gradle is indexing or Gradle's building, and you hit the stop button and then nothing happens, freezes, right? So build performance, I think, is an integral part of all of our lives. And I share the same pain that you guys do in common. The other thing would be the documentation. So if you're building tools in-house for your other engineers, when you have a lot of teams, you want to have very, very robust documentation in place, in-depth information that's available for people to refer to so that they don't have to interact with other humans. Because A, it wastes time answering the same questions over and over, or B, your other counterpart could be in another time zone if you have a global team. The next problem that we face is with the CI and CD pipelines. So lint is failing or tests are flaky and things like that. Another problem that we also face in our development environments is the real device testing environment. So one device that's connected to your USB cable, to your laptop, works fine, but think of it when you try to use the Firebase Test Lab or a device farm where sometimes the devices would time out, run out of memory, RAM, whatever, and then suddenly all your tests are failing and you cannot merge. So that also matters and comes under the developer experience as I see it. And also like your mocking, A/B testing tool chains, like how can you test really, really quickly without having to do all the steps that are needed every single time you build the app. And then also instrumentation that you're allowed to do within your products. And let's look at why should you even care about it at a philosophical or from a business standpoint, I think the first reason is efficiency. So good developer experience usually allows engineers to accomplish a lot more in a lot less time with a lot less frustration. And I think that's the key thing that I want to say, which means a lot less frustration, which we will touch upon at the last point in these reasons, that why is frustration a big deal for teams that are actually building developer experience stuff. And this is particularly important because we have multiple versions that are going out as a mobile team, and the build times are slow. There's a lot of fragmentation on devices. Release times are slow because you can't just ship something. It has to go through a whole process, and then you can't roll it back easily. Configurations can be very complicated to set up. So that's why efficiency is one of the important reasons why you need to care about when you're looking at developer experience. The second part is quality. A streamlined and an effective development process usually directly influences the quality of the final product that you're trying to ship. And easier debugging, faster build times, better testing frameworks in place, and a lot of automation allows developers to focus on being creative and solve problems which they are meant to solve, and that leads to a higher quality product rather than doing the mundane tasks which you can usually offload to a bot. The next point is innovation. When developers, again, spend less time on repetitive or mundane or boring tasks and troubleshooting, they have more time to innovate, implement, and experiment with a lot of new features. Some of them are going to fall on their face, but some of them can be game changers for your product, for your business, for your company, maybe even get you a promotion. Next point is scalability. So as projects scale, the complexity is going to increase. We all know it. But a good developer experience means having robust systems that can handle growing teams, code bases, and the complexity of the feature set without a decrease in productivity. And your developer experience should easily be able to handle new people joining in the company, or even when people are moving from one team to another. And the last part is the attraction and retention. This primarily goes on to talk about the talent that you have in the company that you're either trying to retain or attract. And companies that usually invest a lot or provide excellent developer experiences, they attract and retain top talent. And there is a reason why everybody wants to go work for Google, Facebook, Uber, TikTok, whatever, because they invest a lot in their developer experience, and they know what payoffs or return on investment they get when they do this. And mobile engineers often prefer these environments where they can work on cutting-edge projects, compose enthusiasts, without being bogged down with any inefficient processes. So what's the scale of developer experience that looks like for our mobile infrastructure or like architecture teams? Our team is about 600 Android engineers strong. We support about 1 billion daily active users globally, both across iOS and Android apps that we have. We release a new version every week, so we're continuously building and shipping product improvements, features, bug fixes. And our teams are spread across globally, across different time zones. And as you can imagine how hard it would be to collaborate if we did not have a good system in place. What does the project overview of the TikTok look like? So as you know, our app is fairly large and complex in terms of both code size and the amount of feature set that we have. And we also have a ton of in-house tooling and libraries and SDKs that are built to allow developers to focus on more important stuff. All of this actually lives inside a monorepo setup. Pretty standard, most big tech companies do this. Our Android app is also heavily modularized, so we have a multi-module project setup. And we have an enhanced version of the Android Gradle plugin that we have a lot of customizations for. We also do a lot of improvements in Kotlin, which we sometimes also give back to the community in terms of pull requests or fixes that are appreciated and welcomed by all the Android open source project or the Gradle plugin or even the Kotlin project. What are some of the challenges that our developer experience team faces or likes to solve for the other developers that work inside the company? So like every other successful Android app, our team deals a lot of issues with regards to build times. both local and in CI. We also deal with a lot of slower indexing and syncing issues in the IDEs, whether it's Android Studio, IntelliJ, whatever we're trying to use. We also continuously want to find ways to optimize our code, obfuscate, and also shrink a ton of code that we're producing on an everyday basis. And with that, because we're continuously shipping, building, trying out new stuff, sometimes there's also duplication of effort, there's duplication of code, where teams might not communicate with each other or might find workarounds for the same problem and end up building the same thing, trying to solve the same problem, but in a different way. And then also there's continuously evolving architectures that are coming out in the community that people want to try, and we want to encourage that. And then also the design patterns that may or may not work for us, but we also still want to encourage people or like not stop teams from trying things that they want to do that. And to solve some of these issues that happen during the build process, whether locally or in CI, a tool was born a few years ago, which was called Byte. What is Byte? Byte is a bytecode plugin platform, which is essentially based on top of the Android Gradle Transform API and ASM. Think of it like a middleware inside the Gradle build process, which at a high level looks something like this. So when you're developing an Android app, or your build process would look something like this, where developers write some code and compile it using their IDE. After the code is written, it's usually passed off to Gradle. Gradle then compiles the source code into some sort of bytecode. And at this stage, the bytecode is going to undergo some transformations. These transformations are going to look like obfuscation, optimization. Maybe you've integrated some library that has a plugin that's going to do something on the bytecode. And now this transformed bytecode is more optimized, potentially obfuscated, secured, and is ready to be packaged into an APK. And finally, the APK is produced when everything's bundled together. So where does Byte fit into this workflow? It usually fits here. Now, before I dive into how bytecode actually works, I want to give a very small primer on what Gradle Transform APIs are and what ASM is. Anybody here has experience working with the Android Gradle Transform API? Just so I know how quickly I need to go through this. So not a lot of people. Fun. So what is Android Gradle Transform? Well, the Transform API usually allows developers to manipulate the bytecode by applying various transformations such as obfuscation, optimization, or library integration. A lot of popular libraries use or used to use this Transform API. But in the true sense, it's basically a way to manipulate the compiled class code or the class files before they're actually converted into DEX files. And a powerful tool for a lot of use cases. For example, if you've ever heard of this thing called Instant Run, it used to work, or it was built on top of the Transform API. And if you've never worked with it, which you guys just accepted or like told me, you must be wondering, why would I even use it, right? Well, the transform usage example would look something like this. Suppose we have a custom annotation in our project. It's called log-a-lot. And it looks something like the code snippet that we have here. We can annotate either a field or a method, and it's going to do something. We don't care what it does, but it's going to do something. Now, whenever we encounter this annotation, we want to emit a log for the method when it begins, and then when it finishes the execution. Now, what's one way that comes to mind that we all would be trying to do it? We'd go manually in the code base. Whenever we find the annotation with log-a-lot, we'd start entering those things. Now imagine doing it over 100,000 files or even like millions of lines of code where you have these annotations spread across your code base. It's going to be a waste of time. It's error-prone. So here is where you can actually use the Transform API. So what does the bytecode look like when you've not transformed it? It basically would look something like this. When you decompile that code, you just see the annotation, the method, it's not doing anything. Now let's say we wrote a simple transformation which is going to add the logger that we wanted it to write once the transformation runs. And this is what it looks like with the transformation. Now this happens during the build process, so you're not doing anything manually. The plugin is doing it itself. Essentially what we have done is we've added the name of the activity in which this log-a-lot annotation was found, and then we've added the name of the method which is being executed, and then any objects that we want to print next to it. When the method is about to return, we also do an exit that we're trying to log. And then if it, for some reason, throws an exception, we're also trying to log that. Now, think of this, multiply this number by howsoever many number of a lot annotations are in your code base. So you've immediately saved a lot of time and automated the process of basically adding logging for wherever you wanted it with this annotation. Still, some of you might be, why exactly do I want to use Android Transform? And there are many reasons, which I'm not going to go all over everything, but whatever we touched upon, so automation, it can automatically inject code into every method that we saw in the example. It saves time and reduces human error because you can essentially just test your the plugin that you wrote, and once that passes, you're essentially good to go and run that transformation in your build process. The second thing is customization. So developers can basically customize what kind of logging level they want or what format they want, conditionally enable or disable the logging, maybe only for certain types of builds, certain types of flavors, and you can do whatever you like at one place, run it across your project, get the output. The third thing is it's very, very non-invasive, right? So imagine seeing these logs that we just saw in our code base coming to you like at every single point of time. You're just encountering for every method that has this annotation, you're reading these logs. The code just becomes unreadable. But that doesn't mean that we should not be logging stuff. If we want to instrument some stuff, if we want to debug some stuff, those logs could be helpful. And so this makes the process very, very non-invasive because essentially the logs are not a part of your source code. They only get added to the bytecode that is being compiled and like now put into APK. And you can simply remove the whole logging by just changing one build configuration. And that's how the source code remains clean, and then you also get the functionality that you originally intended to add to your code base. So automation, customization, and non-invasive modifications. We learned about Android Transform. Let's quickly hear about what ASM is. So ASM essentially is an all-purpose Java bytecode manipulation and analysis framework. The goal of the ASM library originally is to just generate, transform, and analyze compiled Java classes. And I think I want to lay stress on the word compiled because that's essentially what it does. And it is usually represented as like byte arrays as they're stored on the disk and loaded into the JVM. And for this purpose and this purpose only, ASM provides tools to read, write, and transform these byte arrays, which by using higher level concepts other than bytes, such as like numeric constants or strings and Java identifiers or Java types or even Java class structure elements. And without diving into too much detail about this, let's try to learn why ByteX essentially was built. The most important thing to know that this was built 3 years ago when we found if all the features that we're trying to develop for our build pipeline are developed as a separate Gradle plugin, each plugin now starts to add time to our build linearly. So it becomes very expensive to run all of these operations. But you could say, well, why don't you shove all of that code into one plugin so it only runs once? Well, then the development becomes a total nightmare, and you cannot manage the code. It becomes very, very cluttered. It's not easy to test. So that's why we need another way to do what we want to do and achieve what we want to achieve. So here are 4 motivations for developing ByteX and then plugins with ByteX that we now use. The first one is code reuse. The common code that is essentially shared by all the plugins can sync into one base module, and it can be reused by all the plugins so that each plugin only needs to focus on the bytecode operation that it wants to perform. The second thing is each plugin code is isolated and decoupled from each other, so easier maintenance, easier development, faster iterations. And based on ByteX, each feature is independent as a single plugin. And because of that, it is very, very conducive now to develop a new plugin. The next thing is faster and efficient bytecode manipulation. Now, because the platformization that makes the transform more efficient in this scenario is class files can now be processed in multiple threads concurrently. So you can make full use of the CPU resources that you have on your machine. And the second thing is plugins are automatically and seamlessly integrated into a single transform task. And that improves the efficiency because you can run them in parallel. And during the transform process, the I/O of the class files that we essentially want to do for transforms is very, very time consuming. And integrating all those plugins into just one transform essentially saves all that time, which you would have otherwise spent reading and writing onto each and every class file in every different plugin. And then last thing is the plugin portability becomes a real breeze. So because each plugin is essentially just using ByteX as a host, you can separate that out and use it in any project or any module that you want without having to run the whole infrastructure that it is running on. And this is how the infrastructure looks like at a very, very high level. Think of it in terms of like 3 layers. The first, the foundation, is built on top of a third-party building block, essentially Gradle, Android Gradle plugin, ASM, Guava library, JSON, and any other libraries that we can think of that we want the plugins to have access to. So essentially, it's nothing but the dependencies for the ByteX middleware layer, which we usually wrap around and expose public APIs for the plugins. In the middle layer, we expose a bunch of APIs. This is to save like boilerplate code that would otherwise be necessary to write each and every plugin. For example, you want logging capabilities. You want a fully hydrated class graph of the project when it's compiled. You want to know about the project, so what's happening in the project, Engine can give you access to that. When a plugin is being run, what is the life cycle of the plugin? And if you want to do things at certain steps, we provide hooks for that. And then, again, tracing and properties and other middleware, which is, again, exposing APIs, so the top layer, where our ByteX plugins live. And these are how the plugins would look like. You could run all of these. You could run one of these, or you could run a combination of these during your build process. Let's have a look at ByteX in actual action. So I'm going to share some examples of what kind of plugins we've developed with ByteX, what problems they solve, and how they kind of work together. These plugins, again, they may or may not be directly applicable to your project, but they should, again, give you an idea of what's possible with bytecode manipulation, because I'm pretty sure most of us don't deal with bytecode manipulation on a day-to-day basis. At most, we just try to decompile the Kotlin code to see what it looks like at the Java level or maybe at the bytecode level, but we don't go in all the time to manipulate the bytecode. And we'll take a deeper dive into one of the plugins and get a high-level understanding of a few more. So one problem that our developer experience teams face is because we develop a lot of libraries in-house and SDKs for business teams, again, to make their lives easier when they're trying to develop features, and even like standardize the use of certain patterns, architectures, or way we want things to be done in the code base. We want to know what's the current coverage of these SDKs or these wrappers or these libraries that we've written. And we also want to understand if there are other teams that are trying to make workarounds or makeshift solutions for themselves, skirting around what we've been guiding them to do. For example, we have wrappers for recycler view and view pagers, which take away a lot of boilerplate that you would otherwise have to write for a recycler view. And it just has some improvements that allows us to do like funky things with the recycler view for which you would otherwise have to write a lot of code. But how do we calculate metrics for how many people are directly using recycler with those like customizations, or how many people are using a list view or a powerful list view or whatever we've built? So the solution is a ByteX plugin, which will analyze the whole app project, and it'll generate which parts of the app are using what kind of an SDK or like the tool that we want, and which parts are not. And at a high level, this is what the overview of the plugin is going to be. When you begin the task for this plugin, it's going to find the usages of, let's say, a power list, a recycler, a power view pager, or the view pager, which comes from the Error SDK, and then all of its subclasses. And subclasses are very important because you could essentially extend from it, and somebody could extend from you, so you also want to capture those metrics in your report. Once you have all that data, you aggregate that summary, and then you write it to a CSV or a JSON file, and at that point of time, your task essentially ends. So how does the working of this plugin look like? Well, we first want to initialize the plugin, so like this is how essentially, after you've written the plugin, you've added it to your base module, which is going to run on the whole project. And you can give it some configuration, which is like common to all the plugins. You either want to enable or disable the plugin. You can decide if you want to run it on a release build, debug build, all builds. You can even specify like certain flavors that you want to run it on. And you can also accept custom input. For example, in my case, I'm trying to ask what kind of log level do I want, which is debug, and what's the scan list going to look like? So if you want to execute my plugin, what are the classes or that you are trying to look for? And I ask for fully qualified class names here, and this is what I'm going to use in the next step. So what you now want to do is you want to create a set of all the classes that include the scan list, but also all the classes that are essentially extending from this, right? Now, Byte makes it very, very easy to do the second part. How do you find all the children of these classes that may be inheriting from each other at multiple levels? Well, you remember I showed you in the middle layer, there's something called a class graph, which Byte provides to us. So essentially, when you know the root class or like the parent class, you can just do a depth-first search, go find all the children of that, add it to your lookup set, and now we know what are the classes that we're going to look for in one, our XML files, and also our Java or Kotlin files. At this point of time, we're going to go through our XML files looking for the usages of any of the classes that were mentioned in your scan list or any of their direct children, and count those usages. Then we do the same thing to find any programmatic creations or accesses in the Java or Kotlin files. And at the end, we're just going to aggregate all of the data and output a JSON file, which would look something like this, right? So let's say we found view pager. There were explicit usages 29, but implicit usages were only 100. And then somebody's also extending from a view pager and calling it a custom view pager, and there's 2 usages of that class as well. And then for the other thing, which is like an extremely powerful list, let's say, we found these usages, but no one else is extending from it. That's why the implicit is only 1, and the explicit usages are 29. You can plot it into a dashboard, do whatever you want with it. You can even prevent people from using certain types of classes. So this is the overall working of one of the plugins that we wrote. Sure, you can do this with Python and other sorts of scripts, but it's just going to be a nightmare. But this very easily integrates into our build process and then pushes everything into the dashboards that we've built around Byte and allows us to capture metrics. Let's look at another problem that a lot of us face. We want to reduce the package size and enhance the performance of our build process and the resource utilization of our app, right? How do you do it? You essentially apply optimizations that can either clean up unused or unnecessary code or resources during the build process. How does this plugin work? We go about finding the unused code in the bytecode and eliminate that. We then scan for unused resources that are not referenced anywhere in the app, like drawable, layouts, strings, PNGs. We can also inline a bunch of methods at call site to reduce method call related instructions. We can also introduce constant code folding by evaluating expressions at compile time instead of letting that happen at runtime. And we can scan for dead code and eliminate that from the code when it's ready to be packaged. Another one of the plugins that we have is the reference check plugins. So in large Android apps, you would know managing references to prevent issues like memory leaks or crashes is kind of challenging. How can we automate this? How can we optimize the references at the bytecode level to enhance the performance and stability of the app? The solution here focuses on identifying and handling unused and problematic references based on certain instructions or patterns that we've set statically into our plugin. And after you find those out, you essentially either flag it to the developer or you go about fixing it yourself if you already know if it's a straightforward fix. And this should prevent issues such as memory leaks, unnecessary resource usage, or like potential application crashes. How does it work? Well, here we use ASM. So the plugin is going to scan the bytecode. It'll try to identify and catalog all the references, their uses, and any potential issues before the that we've mentioned in the predefined rules and patterns. After the analysis is complete, you can either report these references, like I said, to the developer by failing the build, or you can even automatically remove it in the CI. You could also just refactor the stuff to use a better version of that code. And then sometimes we can also use this to guard against the min API usages, which accidentally can cause instability in your app. So this also works there. Another one of the plugins that we had when we had a lot of Java code, this was very, very helpful, is a plugin to basically inline getters and setters. And the plugin essentially identifies getter and setter methods in the bytecode and replaces all of these calls to the direct field access in the bytecode. During the build process, basically you're going to again scan the compiled bytecode of the application, identify all of the getter setters. They're typically small methods used to solely retrieve or set a value of something if you've only started writing Kotlin when you started doing Android. But it analyzes the usage of the context of these methods to ensure that the inlining won't cause any side effects. And it will check whether the fields are accessed only within a class or if inlining might break encapsulation in a way that it impacts functionality. And only then and then it will actually act on what it's supposed to do. And once it's safe to inline, the plugin automatically replaces these calls with the direct references, like I mentioned, to the fields that they encapsulate. And the replacement, like I said, happens at the bytecode level, meaning the source code, again, remains unchanged. So for the developer, you're still reading the same thing, but the executed code is a little bit optimized. How does ByteX actually integrate with our build system? So we saw where it actually fits into the dev flow, but like how does it integrate? It usually gets invoked when you run Gradle and the build process of the Android application. And it is basically working with the Android Gradle build system. And it is added as a dependency to the build.gradle file of the root project. And it registers itself as a transform task, which means that it gets access to the whole project, the compiled bytecode, before the code is actually ready to be packaged into an APK. How are the plugins registered and controlled? The plugins are registered and controlled in the very similar fashion I showed you. You can either put it on a separate module that you want to try to manipulate, or you can put it at the main project level. And the registration process is as simple as modifying the build.gradle file to include ByteX and the plugin as a dependency, and to configure it to apply specific logic that you want for your plugin. Each plugin is usually controlled, as I showed you, through a enable flag, which is common across. And it can either be set statically, like you could say it's true or false, or you could even have some sort of a dynamic configuration that you only want certain plugins to execute when certain conditions are met. So certain plugins you only want to execute in CI, so you want to check for the environment variables or do certain things. Certain things you only want to do when a variant is being built or a flavor is being built. All of those things are possible with ByteX. What are some of the benefits? Just like some examples I shared with you, we build a ton of custom plugins purely for our feature or business team. So when we know like certain teams are trying to do same things all over, we want to pull that out and try to automate that process. So business teams can offload the same work or boring or mundane cleanup kind of stuff to this plugin. We can also build plugins that optimize stuff for the developers in the CI based on pre-configured rules and design patterns. For the UI stuff that we have or the MVVM layers that we have, we can do a lot of optimizations through these plugins. And then these plugins can also be used in addition to the static analysis that we all have access to through the open source community, but we also have a lot of pre-configured rules that we write to prevent certain things from shipping out in production. And last but not the least, you can use a lot of these plugins to collect metrics and insights into your code base, and then try to either improve those things or provide insights to business teams if they're lacking in insights into what's happening. And you can use that to your advantage as a mobile infrastructure or developer experience team, because that's the data that you need to act upon problems that you're trying to solve for other teams. How does the scalability and maintainability of these plugins look like? Basically, by reducing the overall size or improving it at the bytecode level, you're decreasing the amount of data that needs to be processed by your build, right? And at that point of time, like if you're trying to do dexing or any of those things, this faster processing on smaller data essentially gives you benefits in terms of your faster build speeds, both locally and in CI. And this is usually achieved through the optimizations that we discussed, like removing unused resources or inlining short methods, optimizing constants, and folding stuff into the, to reduce the complexity of the operations that your app's trying to perform. And then how can we achieve parallelization in our build process is basically it's designed to leverage the parallel processing capabilities during its bytecode transformation phases. Because we only run one transform task, all the plugins run in parallel inside that task. Last but not the least, you remember I mentioned this was developed about 3 years ago. That's when transform was still a thing. However, in AGP8, transform has been deprecated by Google. And now you can use a new instrumentation API to transform the bytecode if you wanted to, in case you've already migrated to the AGP8. And the recommendation is use the instrumentation API. For libraries, you can basically register instrumentation for local project classes only. And this basically restriction allows them to do these transformations really, really quickly, which was not possible in the old times. And it basically improves the performance for both the full and incremental builds that we have. I don't know if I have sold you on improving developer experience yet or not. If I have, then my colleague Pongwon will be presenting a talk on how you can compile your Kotlin code about 2 times faster on a fairly large project in the room Robertson 2 and 3 at 4:25 p.m. today. And that's all I have. Thank you so much for being such a patient audience.